Alright, good morning everyone. It is puking outside in terms of snow. It's pretty bad out there. We are staying indoors and we are playing some more Spaceflight Simulator. This is Kerbal Space Program 2. Played a lot, I love it. And there's a big update recently that added thermodynamics to atmospheres, re-entry, and just made everything a lot more stable and more performant. So we're going to record this, test audio, test computer's performance, and we're going to work on our mission to Jool. Jool is this game's Jupiter analog. We're going to launch a satellite out there, but first we're going to launch a long-range satellite that is inside of this fairing here into an extremely high Kerbin orbit. Kerbin is the Earth analog. Everything in this game is scaled down by about a factor of 10 to make it so that the game can actually be run on computers, but it's also 10 times denser, so gravity, the atmosphere, everything is as it should be in our solar system. So this is true spaceflight simulator. What we have here are 6 SRBs, or solid rocket boosters, to get us up into space. And we have a core with an overwhelming amount of thrust to push us out into orbit. We have 9,300 meters per second of delta V. Delta V is thrust represented in terms of meters per second. That is an overwhelming amount for what we're doing. I did make a recording before this. It didn't capture the video. So we're re-recording it, and I noticed the first time I launched, it was supposed to be an uncrewed flight, but Jeb had snuck on board, so we're going to make sure that Jeb is not in here, and then we're going to launch, and we'll see what happens. Alright, we have about 1.6 thrust-to-weight ratio. The boosters are going to launch first. We'll stage them out in space, jettison our fairing. Our fairing is going to protect our electronics from overheating while we go through the atmosphere. We will kick in our liquid fuel engine, our Rhino engine. That should carry us the rest of the way. Let's do it. We're going to be doing a gravity-assisted turn at probably 1,500 meters. Be at like 150 meters per second. Try and get you 25 kilometers up. Our gravity turn if we can. This yellow circles are for gray crosshair. We need to keep for whatever was inside that crosshair. SAS stability assistance, we do have that, and we are going to point prograde. We're going to coast a little bit until we get to our apoapsis, which is our highest point in orbit. We're not actually in orbit yet, but at that point, it's where we can burn most efficiently, and we are going to plot a course prograde at that point to get our orbit. And we will coast until our maneuver node in T-minus 3 minutes and 30 seconds. The 3- crosshair is our target for our course. Stability assistance is programmed to follow that. Okay, had to pause it there for a second. At this point, yeah, we definitely have an overwhelming amount of Delta V here to get us where we need to be. And that sneaky Jeb is no longer on board. At this point, we can jettison our ferret. It's gonna look a little weird, but whatever. Oh, that looked pretty good. Sometimes that glitches out. And now, you can see our satellite. And since we are now in vacuum, let's start up all of our electronics. And this should give us more than enough range to communicate with satellites out in Jool. Jool, unlike Jupiter, is green, which in real life gas giants are not green, and I don't think they can be. But it looks really cool. And Jool has the radius of about Earth, but again, it's 10 times denser, so it has a huge sphere of influence. It's pretty easy to hit it. And Jool's atmosphere will be starting at about 150 kilometers, and we're going to try and dip a probe into its atmosphere and get some atmospheric samples and get it back if we can, but we just need some increased range for communications. So we're going to launch this first. This does have a docking port on it. If we wanted to, we could put a Kerbal on a ship, fly it here, dock with it, refuel it, pilot it, whatever we want to do. It's a large satellite. And we do have time dilation because it can take years to get to another planet. So we have to fly all the way around the sun. Kerbal is what it's called. We're going to use the time dilation to speed this up just a little bit. I'm 17 years into this campaign. Mission time, 5 minutes. About halfway through our tech tree in this game. I want to do a crewed mission to Duna, which is our Mars analog, but I feel like I need some new technology for that, so we're going to fly to Jool, which is easier to send an unmanned mission there. We're going to get a bunch of science. Okay. Periapsis is our lowest point. Negative means we're on a crash course. We need that to be positive. And again, the atmosphere of Kerbin ends at 70 kilometers. We're going to be pushing out further because this is a long-range satellite. We're going to push it into an extremely high orbit. We have short-range and mid-range satellites in closer orbits and around the moon on Kerbin. Kerbin actually has 2 moons. The second one is named Minmus. We have a satellite in orbit around there as well. We also have satellites around Eve, which is our Venus analog, and Mars, but they're all mid-range. This is our first long-range satellite in this campaign. I think I hear a cat. I don't know if the cat's coming up in the audio or not, but there's definitely a cat meowing. The number for the burn timer, I don't always trust that. The math doesn't always add up. And we're going to be using these a lot more when we actually get to Jool, because Jool has a lot of moons, just like Jupiter. And we're going to be using gravity assists, and we're going to be using all of these to get to Jool as efficiently as we can. This is prograde, which means orbit out. Retrograde is orbit in. And we have radial in and out to move. Let me rephrase that. Prograde will increase our speed, retrograde will brake. Radial in will push us towards a planet, or the sun. Radial out pushes us away, and the radial in is really useful for getting a gravity slingshot around a moon. Normal and anti-normal are basically north and south, at least for Kerbin's orbit. Once again, our periapsis, that's the lowest point in orbit, we're going to be going the fastest. And so when you want to make a course, it's always good to do it there. And we're going to push way out. Way out. Way out there. Not that far. That's good. It's a very oblong orbit, but once we boost out here, we're going to be traveling really slow. It's just Newton's law. Whatever goes up must come down, so we're kind of on a ballistic trajectory right now. We are firing something straight up. It's going really fast right now at 2,200 meters a second. Up here, it's going to be going really slow. That's the peak, and then it's going to start falling back to Kerbal, but before it falls, we're going to circularize out there. So we're going to be in a very slow orbit around the planet. And I suppose we will use time dilation again here. Oh, there's the moon behind us. At this point, I'm going to burn looking at this map to make sure that we are not at a point where we escape Kerbin's sphere of influence. And this doesn't need to be exact. Now our highest point is at 82,000 kilometers. Keep an eye on that speed. This would take days to get out here, so we're gonna use a lot of time dilation here. Keep an eye on that speed. Let's see how much it drops. We're gonna be really slow out here. And we will also need to circularize. Oops, not that much. You see, it's going to take our craft 20 days to get out there. We are going to not wait 20 days in real time. We could, but be a long time. So we're going to time dilate. You can see we are now only going 27.5 meters per second, which is incredibly slow. But out here, a really small amount of fuel will get you a long ways. Again, it doesn't have to be perfect. That was a slingshot out of there if we had stopped there. Hit the moon's sphere of influence. It doesn't have to be perfect, but that's pretty good. Okay, that is a not quite circular. We're 2,000 kilometers off, but it's pretty close. And we even have enough fuel to spare to get us down if we want to, or maybe put this in orbit around another planet if we want to. So we're not going to stage this. There is another fuel tank in here, and there's another thruster pack in here. But this is fine. And there's Kerbin way down there, and the moon. And I guess before the second half, when we actually launch, we'll take a look at our communications network. The first video I published, I had launched this into orbit. This is low orbit, short range satellite. Excuse me, that's your mid-range satellite. That's not what was seen. This is what I launched in that first video. That communicates with this. Our mid-range satellite. That will communicate with either the satellite around the moon. If I can find it, where is it? It's somewhere. Definitely somewhere. Let's get to the daytime side of it to see what's going on here. There it is. It's so small. And the 3 short-range satellites can also communicate with each other as well. There's our mid-range satellite. If we go further out, we do actually have a satellite in Eve's orbit, so when we're around the sun, we have a way to communicate. This is a longer range satellite. That is Eve, our Venus analog. Yeah, I know I'm colorblind. I don't know what color that is. It's not green like Venus is, but the atmosphere is just as thick and soupy, and it's just as hot down there. I do have a lander down there as well. And further out from Kerbin, we have a medium-range satellite in orbit around Duna, which is our Mars analog. And there it is. Let's get to the daytime side of Mars. It looks really cool. Or Duna. sunrise over Duna. And that is our communication network in place for a mission out, not to Dres, to Jool. Ugh, there we go. It's Jool, our gas giant. It has 5 moons: Lathe, Vol, Tylo, Bop, and Pole. And tentatively the plan, we're gonna have to be patient with it, but I've done this before in other games. Tylo has a pretty heavy, pretty wide sphere of influence gravitationally, so we slingshot around here. Its gravity will help us brake and capture to Jool without using as much fuel, and if we can, we stop by Lathe, dip into Lathe's atmosphere. It does actually have an atmosphere. That is a neat place that I kind of want to stop at. That's awesome. We collect atmospheric data from Lathe, we brake with Lathe, and we go into Jool. Dip into Jool's atmosphere if we can. Get atmospheric data there. Transmit what we can all the way back to Kerbin. And if we can, fly the probe back as well. That's the mission. And we are going to build a new craft, and I'll be back for part 2. I guess while we listen to this amazing music, I also want to say that Dres is the 4th planet from, but it's actually a dwarf planet. It's like Ceres in our own solar system. It's hard to get to. I've been there once. I didn't leave anything in there. It has a really high inclination compared to Kerbin, so it's hard to get a rendezvous with it. Same for Moho, the 1st planet. Moho is a Mercury analog. We do have a mission to land up in a big sinkhole up here. We're not going to do that right now, though. It's hard to get here, too. It's really hard to get here. Alright. I don't know if part 2 is going to be its own video or in the same video, but this has been a test. It's been a fun mission so far, and we'll see about doing some more and getting some more posted to the YouTubes. See ya. Alright, welcome back to Kerbin. This is still the same day, just took a break, got some lunch, walked the dog through the puking snow, have some hot chocolate, time to continue. Still not sure if this is going to be in the same video as the first one or not, we'll find out. This part of the mission is going to be longer, but we need to build something, and I was working on something last night. I'm not sure how it's going to work out, though. So for this, we have the same 6 solid rocket fuel boosters, and we have a liquid fuel core, a planetary transfer stage, which is going to be new for the second part of this mission, and then our Jool phase, which we are going to be relying on as much as possible before deploying our probe. And for that concern, we have an orbital engine inside this cowling. We have monopropellant thrust too, just for a bit extra. And at the top, if we can utilize it all, we do have an atmospheric probe. And instead of a fairing, we have a cargo bay, and there is a science module in there, so we can do some science in high orbit, low orbit, in the atmosphere. And then this is our probe. And I'm not sure on the stability of this. We may need to redesign this rocket, but it's like really tall. That's my concern with it. I think we need some struts as well. These are really heavy. And I do not trust that the decouplers alone are going to hold these. So we'll just add a couple of quick struts in here. Hopefully that's fine. Interestingly, even though this is such a... it's way larger than the other rocket, we have... I'm not sure I entirely trust this, but the game thinks we have less delta V than our smaller rocket. Less fuel, in other words. But yeah, we have the solid rocket fuel boosters are gonna launch, take off, jettison, hit our main core with that Rhino engine on the bottom, hopefully in space. Stage that to our transfer stage, which I think is a mainsail engine. Yes, it is. We'll stage the transfer stage once we get into Jupiter. Jool, excuse me. And then we will rely on thrust of this top science core once we get there, and then take the probe home if we have enough fuel. That's the plan. Now before we do that, we need to get to a transfer window, which is going to be new for this second part. With enough fuel, let me destroy these. We're gonna launch some missiles at the stages from the last rocket that are in orbit. There we go. They're gone. So with enough fuel, you can brute force yourself anywhere from Moho to Elu, which is our Pluto analog, without a transfer window. But to boost efficiently, we need a transfer window. And for Jool, where is it? Jool, there it is. That's dress. Jool, there it is. We need to be at 12 o'clock. When plotting a transfer, Kerbin should always be at 3 o'clock. And for even Moho, they should be behind Kerbin because they're going to be moving faster. But for Duna, Dress, Jool, and Elu, they need to be further out. Duna is usually tangent at about 45 degrees. Jool is 12 o'clock. Dress is somewhere in here, but with an inclination change as well. So we need 12 o'clock, and we're going to warp to that point. We're, again, 17 years into this campaign. And Kerbin being closer to Kerbol is faster than Jool, so we are going to get around it before it gets around us. Again, that dot is just a mission I have on Moho to land in that sinkhole. It's not actually the color of that planet. Let's go a little faster. Getting close. A little more, I think. A little bit past the transfer window, but it's probably fine. That's probably fine. Now, of course, this rocket may not work at all. I'm at least counting on it not being very stable because of how tall it is. We'll find out. And of course it changed from 9100 to 4400 delta V, which is not accurate. Yeah, it's don't see any flux or wobble. So we're gonna launch. The engines are gonna fire, and then we're gonna detach these during the atmospheric takeoff. I realized during the first half that you couldn't really hear me, so I'm not gonna be talking. Ladies and gentlemen, is what happens when you leave an unstable rocket and you lead it too far outside of that prograde crosshair. It just tips over. So we need to do a bit of redesign. No one saw that. That never happened. Nothing happened. Now, how can we fix that? Everything's lined up pretty well. I think there's a leak in the memory, and performance is lagging behind at 11 frames per second, so we're going to do these redesigns, save the game, relaunch it, and then try and take off again. I think the plan is going to be to take away the SRBs and replace these with liquid fuel boosters that have stabilizers on them and a little bit more gimbal in their engine. And actually, let's save it and relaunch the game because this is an awful frame rate. Alright, here reloading the game, and we are going to do those redesigns I was talking about, and we'll see what happens. There's Val, swimming towards your craft. Let's get into it. By the way, the name of this campaign is I'm Sure It'll Be Fine, as we saw with the last takeoff, completely flawless, right? Anyways, let's get into it. Okay, we're no longer looking at a PowerPoint presentation. I normally get better frame rate than 52, but again, I am recording this. And just for those curious, I am recording this and running this game on an AMD 7800X3D processor and a 7800 XT graphics card. We're running Pop! OS 2204 in the Linux 6.10 kernel, for those who care about system specs. So yeah, the plan is going to be to get rid of these. We're going to leave this core alone. We need that transfer stage and we need that science core up top. There's just not much I can do about the height. But can do something about the gimbal and our boosters. We can can also add some stabilizers in here as well. I'm not sure to go with 6 medium size or 8 small size. And we can either choose to go with a single sustainer methyl oxygen, such as the mainsail and the skimmer. I like the mainsail myself. Or it won't last as long, but it'll definitely push us faster. We can go with 4 vectors. 4 vectors on the bottom of a single booster. For the top, we could add more fuel, but I think we're just going to have empty structure for aerodynamics. That. We can have 6 of those. If we did that, what would our thrust to weight ratio be? Let's see. It's not exactly how I want them. Raise this up. I'm gonna make it even taller. There we go. .6. That thrust to weight is so high, we would accelerate so quickly that we would likely overheat the atmosphere. That is too much. So what happens if we take off these and just put the mainsails on? Let's get rid of these unneeded stages. That's .6. That's not good either. Well, could go with. I really like the vectors, but if we need to go with something either less powerful or less vectors, one or the other. Let's see what 3 vectors on each booster does. And let's move all of these together. Okay, that's 18. It's also 0.655. If thrust to weight ratio is below 1, we will not take off. And if it's below like 1.3, we will be extremely slow and unstable. We only want 1.5 to 2. So that's not going to work. Let me look at this again. Not view. Let's see. It's 24, 4 for each booster. Something's not showing right. We should definitely have above 1 with that. I don't know. Let's just test it and see what happens. I haven't added struts either. but I don't think this is going to be as heavy as our solid fuel rocket boosters. Let's see, what's this? 32, 64 tons. Roundabout, without the engines. What are these? 144 tons, so this is a lot lighter weight than the solid fuel rocket boosters. What's our center of thrust, center of mass? So that looks a lot nicer. Before everything was lined up in the middle, now thrust is down here where it should be, and our mass and pressure in our main core. This could still wobble around, glitch out, and blow up, because that is all that's holding these onto our main core. We can try it. Let's see what happens. Okay, it's holding its own weight. Let's take off.
Zaid, Eveun, Oko, Eteis, Sier, Oknik, Ortau, Fer, Sol, Onu.
While I agree that definitely looked cool, we definitely didn't get where we wanted to go, did we? At least we proved that our thrust to rate ratio is definitely above 1. The game's math is incorrect. Good old Kerbals. Up to their Kerbal shenanigans. Let's put struts on these stabilizers. And we will strut our fuel cells. So we have everything nice and locked down, and when we decouple, these struts just blow off the side. Kind of like the explosively launched parachute on the back of the space shuttle. In real life, they just kind of blow off the side. So that should be a lot better. And for some added assurance, we're gonna put launch towers as well. Lock them in. Okay. And for the best reliability, these need to be above our boosters. So boosters, disconnect from the ground, run out of fuel, decouple, ignite the main core. If we have enough fuel, we can also use the main core to eject from Kerbin's SOI, as well as sphere of influence. Disconnected mid-transfer or while we're still in orbit, and then ignite the transfer stage. And again, if we have enough fuel, use the transfer stage up in Jool's sphere of influence, break off when we run out of gas, and then rely on the science core for everything else. Again, it's still really tall, and I'm nervous about the stability, but we'll find out what happens. And we're just gonna skip the countdown this time.
Zaid. Ose.
And that was a lot more stable like I thought it would be. The solid fuel is a lot heavier than the liquid fuel. Ooh. That's not great. That's better. How much delta V do we have in our boosters? 230. So yes, we are going to have to achieve orbit with our main stage. At Apoapsis in T-minus 140. Because our rocket is a lot heavier than the first one we launched with that satellite, it takes a lot longer for our stability assistance to point us in the right direction, but it's getting there. We're in vacuum. We can extend these. So that we can communicate. And so that we can charge our batteries. This is going to be really quick. We are probably going to ignite and disconnect at the same time. Yeah. Alright, T-minus 40. Moon must be on the other side of Kerbin right now. It's gonna be a long burn of 320. Here we go.
Are going up.
Well then, guess we're not going to Jool. Let's reload that and stage it correctly instead of being in a hurry. Because that was a disaster. Larger rockets right now are a little finicky sometimes. The devs are working on it, making it better. Alright. Okay. What is our rocket doing? It's doing some weirdness. I'm sure it'll be fine. Famous last words in this campaign. Yeah. Ah, I see what it's doing. I don't understand. What? What is it doing? prograde. Let's just point prograde and not rely on the computer to do it for us. Because we're running out of time. We need to get in line now. We have 15 seconds to get in that crosshair. As long as we're in the crosshair, we should be fine. Our engines, once they throw,
Aloha Edra.
also get us pointed in the right direction as well. It's a little wobbly, but it's fine. It's fine.
Osene.
Alright, we are clear of that nonsense. Gonna point the nose up a little bit. Ideally, we need to stay behind that apoapsis. It's not gonna happen. We'll see what happens. We shall try and speed up a little bit. This is dangerous to speed up while thrusting, by the way. Never do this if you decide to play Kerbal. We should be fine. Eventually you're gonna have to be able to speed up while boosting, and I'm sure it'll be more performant by that point in time, but the developers are planning on adding in other stars you can travel to. And you'll have to like boost for hours, weeks, years to, I don't even know how many, you're gonna be traveling light years at that point. Okay. Positive periapsis. Need to get into at least 70 kilometers, preferably 80, just to have a little wiggle room. There we go. Alright. Took us a minute, but we finally got our Kerbin Orbit. Now, Jool. Not stress. Jool. Set target. Why are you back there, Jool? I went to the tracking station and gave us a good transfer window. What happened? Now that we're in orbit, it's gonna take too long for Jool to come back around. Like, we need time dilation up here. And 1 million times speed to get Jool where we need it to be. Like, we're at 3 o'clock. Jool's down here at 5. That's just not gonna work. Not efficiently, at least. Jool has a massive SOI. We can just try and brute force it. I'm not sure if it would work, though. We'll try and brute force it, and I guess what we'll do is, like, I really don't want to go through that launch again. Like, we got it up here. I don't want the shenanigans again, so we will leave the sphere of influence for Kerbin, get around the sun, and then try and plot a course correction to get to Jool and just brute force it with just sheer delta V. If it doesn't work, we will get a new transfer window and we will cheat a little bit and get ourselves back into orbit by teleporting our craft. Which, I know it's cheating, but hey, I already got up here. I don't want to do it again. This is already a long mission as it is. So we'll see what happens. We're going to point prograde, and we need to start burning probably at our highest point here because it is on the backside of Kerbin. Kerbin is traveling that way, and we want to increase our orbital height on this side. So while we'll be traveling slower here than here, we want to start burning here, just for efficiency's sake. So let's push it out. Without a transfer window, this is not only going to take more fuel, it's going to take more time as well. This isn't a crewed mission, so it's fine, but... Alright, we're getting out there with 941 delta V. Let's see if we can back off a little bit. Not that much. 937. So we can start with our main core, but we will have to use that transfer stage for the rest of it. So while we're waiting on this, we need to rename the fly save to actual name. Comsat K-1L. Jool. Focus. You know, if we're successful here, we'll get a ton of science that we can use to research new technologies, and we should have enough points available to research technologies that should make it so that I feel confident in a manned mission to Duna, which would be fun. I've already landed a crew on Duna's moon, Ike. Ike doesn't have a lot of gravity. I mean, it's kind of obnoxious for a moon, but it's easy to land and take off from. And when they got back, no one died, no Kerbals left behind. Duna's a lot tougher, though. There's an atmosphere, and it's a lot more dense. And more massive. One of the moons that we're going to be trying to touch, Lathe, actually has a nitrogen-oxygen atmosphere. Jets work in that moon's atmosphere. So one day, if we get enough into it, we can make a space plane and fly a jet around Jool's moon, Lathe. That'll be fun. Let's rotate this a little bit. Just get a little bit more electricity going. There we go. We can also open this. I'm not worried about drag anymore. T-minus 1 minute. All gone. Unfortunately, I think we will be able to brute force this because we are escaping Kerbin with most of our core stage. So any corrections we need to make, we can just do with that transfer stage, which is good. So I think we'll still have some success here. And of course, the further away we get from Kerbal, our sun, the less effective these solar panels are going to be. But on our probe, we have a lot more of them and heavier batteries, so it should still be enough to get us powered. Let's go out to the map. Of course, this line is our plotted course. Again, colorblind, not sure what color it is, if it's yellow or green, whatever. I don't care. Pick on me all you want. This is our actual course. They need to line up. We're basically gonna kill it as soon as the blue and yellow or green or whatever the hell match up. It's not gonna be in this stage though. Just like that, and we are off on our transfer stage. We are at escape velocity. We will be leaving Kerbin's sphere of influence in around about 16 days. Let's time warp. Okay. We have left our home system and we are now in Kerbin Orbit. Now we need to find a course. That's Elu. That's Jool. Okay. Our descending node is right here. Let's see what we can do with it. That's a lot of power. That's our descending node. What do we get? It's not even close. We're getting there. It's not counter, but it's 2,700 delta V to get there. What we should probably do is reload and get a gravity assist around the moon and then try this again. Can we do that? That would help us a lot. So, for the moon, there you are, moon. What we generally want to do, let me focus on Kerbin, and we want to start burning right about there, is how I usually do it. We can use a lot less fuel. We can use the moon's gravity to push us out further with less fuel. Watch that line go up when we get close. That'll also change our inclination, which we don't really want, but this is a cheaper way to do things. Oops. We also don't want to crash into the moon. Can we get it on the other side? That will push us out a lot further for about 100 less delta V. But again, it changes our inclination a bit. The tighter we get into the moon, the faster we go. Let's see if we can back off a bit. So that's like halfway between Kerbin and Duna by doing that. So we're gonna try that. You guys will get to see a flyby of the moon as well. And we will be going very fast as well. I believe before I reloaded I saw 9,300 meters per second velocity. This should make us go even faster. We should be able to get to Jool a little bit quicker. We have 17 minutes to wait for this, so once we get in line, we are going to time dilate. With the moon. We're looking at another PowerPoint show. It's whatever. And we're gonna be hugging the moon so tightly. We're gonna focus on this during our burn. Getting around by the skin of her teeth here. set to crash directly into it, but what we're going to do is we are going to turn around backwards, with our butt facing towards the moon, which is right up there. We're going to limit our thrusts as well. It's fine. Alright, we are in line with retrograde. That's still too much thrust. Let's bring it down to like 10. It's fine. Okay, this is our prograde marker that will be pointed straight at the moon. Now our thrust is really low, so we can really fine-tune this. Just fluttering the throttle. We'll be 6 kilometers above the surface when we fly by it. But it doesn't have us leaving. I think we need to back off a little bit. That's too low. Okay, we are retro again. I think the game's math was not giving us the correct information. Because I can't get an escape velocity now. Let's hit RCS for a second. Wait, we were supposed to be on the other side, weren't we? That's how we get our escape velocity. That's a waste of fuel, but we'll be fine. Live and learn. Okay. There we go. We want to be, I think, a little bit higher than 50 kilometers, though. Bring the thrust limiter down even more. So we can really fine-tune and hone in on this periapsis. Because we definitely don't want to be 50 kilometers, we want closer, closer. 5 kilometers. Where's that put us? Well, it puts us somewhere, that's for sure. So we will be skimming around the moon 5 kilometers above its surface, barely above it. That'll be a show at least. If this mission fails, we'll at least look cool failing. And once again, I'm sick of this slideshow, so we are going to save this and reload the game. This memory leak happens less frequently. They say they fixed it. I don't believe them, though. Alright, let's kill the game and reload it. Okay. Looks like we're still recording. Should be good. Alright, we're back at it. We're gonna point prograde here. Their nose pointed straight at the moon. And I did bring that thrust limiter back up, yes, yes. We still have 1100 delta V in our transfer stage, which should be enough for course correction when we get around the sun. Excuse me, Kerbal. So we are going to be flying by the moon this way and flinging on around. Now, if we were to wait to get to the moon, our encounter would be... we'd have to wait like a day. So we are gonna time dilate. Okay. We're also going to destroy our debris, the missile. Alright, when we enter a different SOI, the music changes. You're hearing Kerbin's soundtrack right now. Nice and mellow. This is the new area of the game. The moon is the first place you're supposed to fly to and land on, and it has like kind of intense music the lower you get, and we're going to be really low. It's a pretty cool track, but I think my favorite music is around Duna, Mars. Let's speed up a little bit.
Until are going up.
Come on. Get in there. It's kind of weird. We're going to change from falling towards Kerbin to falling towards the moon. But we're actually falling in a different direction now. We are going to be very close. We're going to flip again. Speed up and get to the fun part. Timer's going down super fast, and we are speeding up. As one would expect when there's no atmosphere and you're falling towards a massive object, you're going to speed up quickly. Of course, we are falling in an orientation where we miss the ground, and we keep going around it. Okay. And here comes our slingshot. Should be fun to watch. We're going to be going so fast around here. Let's also get these solar panels out of the way. Line it up nicely. There we go. Craft is tilting. Also, it sounded like something just broke. I don't like those crashing sounds. Looks fine. Actually kind of worried about how low we're going to be, but the math says we're going to make it around, so let's trust in the math. That says we're gonna be crashing. No, we should be fine. Oh, I see, that's escape velocity. I was reading it backwards. Our altitude is definitely going down below what I had it set to. Again, it should still be fine. I don't always trust the math with Delta V in this game, the burn timer, but the maneuver is usually correct. We are now way below where we should be, so I am concerned. We need to get up. We need to get up. Up. Burn. Burn. Okay. All right. That was scary. I think we're climbing again, though. Whew. was a close call. There's a nice shot of Kerbin out there. What we could probably do while we're at it, we could probably get a bit of science here. And then, let's see. Once we get back into high orbit, we might be able to do that again. It's not a lot of science, but it can help. We did that burn when I didn't do. Where are we gonna be going now? Should be good. See, that little correction that I did out of fear hasn't really affected it too much. We need to get back into high orbit and we'll run the science probe again. And then before we leave, we'll transmit that data. Wait, can I get science twice? Not really. Let's time dilate until we get back into high orbit above the moon. Moon. Something like that. It's moon. We just say moon. Okay. Go. Let's transmit that. Now, let's boogie. Once again, back in Kerbin Orbit. Alright, now we need to get to Jool. We're just gonna have to play with the nav ball for a bit here. Ideally, we want to get an encounter at least before we ditch the stage. Hopefully we can do that. What was that? It's just spinning around. So we need to get to Jool for less than 1059 Delta V. I don't see it happening. We could maybe boost around Duna as well. Let's see if we can. We're gonna have to play with this a little bit. close there. Let's do... Okay. Now once again, just like with the moon, we want to get really close. So we want to go bring that down. Bring this in. Oop. We definitely don't want to go out like that, that's for sure. Maybe just get it as close as we can and then correct when we're there. That'd be very close. How far does that get us? Really doesn't get us a lot further, and it only serves to change our inclination, which we don't want to do. Maybe that's not the greatest idea. That gets us out there, but it doesn't give us an encounter, at least not yet. That does. But it's very expensive. Very expensive indeed. what should we do? Oops. Let's reset, redo. Better, my headset's getting low. I'm not sure we're gonna be able to finish this in time. Let's prograde a little more. A little less. Probably a little more. What's that give us? That seems like the best we can do. It gives us an encounter. We're gonna have to go for it. Now again, because we are on the wrong side of the sun, this is gonna take us 278 days before we can launch, but this is not a crewed mission. So let's time dilate by 1,000,000x. We still have 3 hours. Alright. We want to make sure we are focusing on Jool because this is like threading a needle where a planet's sphere of influence is the hole in the needle. Your trajectory is the thread. It's kind of hard. We may need to correct again, but we'll see what happens. Again, it's not a crewed mission, so if we fail this, no harm, no foul.
Aloha Edra.
Since we're going to be burning for 5 minutes.
Hotel block.
Okay, we're getting close. So once again, it's also taken a lot more fuel than I thought. This had 2,600 burn on the chart, but this had 2,000. We had 1,000 left in the other stage. This is taking a lot more gas than was calculated. Okay, that's an encounter. point. How long is it going to take to get there? 284 days. We need to launch a missile at our debris, don't we? We don't want to clutter up everything. There we go. And how much is it going to take to circular or capture? More than what we have in this stage, that's for sure. Okay.
Você sair ali?
God dang it. There we go. Okay. Now we need capture so we don't fly right by. Ooh. Okay, that's... Let's start with the gradual. See if we can capture with just what we have. We can't capture with just what we have. We can do it fairly affordably, and we still have this stage left. We have the monopropellant as well. This will probably be fine, at least for getting some science. We also need to change our inclination a lot. We're slowly losing electrical charge as well, but we can get electricity from the engines when they fire as well. The solar panels just aren't as efficient out here. When the stability assist isn't running, it looks like it can just keep a charge. Alright, this is when we tie that knot around the needle. Actually, let's put this monopropellant here. Alright. You know, we don't even really need to get this probe home either. It'd be nice to have the atmospheric samples, but if we can just transmit the data, we'll still get a ton of science. Are we going to have enough monopropellant? That's a real question. We're going to capture... Oof. Just shy. So we are going to have to deploy the probe. We can use this at least. And from that, we have 200 science from Jool high orbit. That's fine. And we need to disconnect that. Need to enable RCS. And we actually need to change to docking mode to get out of here. If we can. I would like to get out of here. Let's do that. Pointing retrograde, and we need to fire that engine. Okay. And we can let that sit there for a minute. I think this mission is going to be a failure. We do not have the fuel that we need because of our inefficiencies with that transfer window to actually get down to the atmosphere. We still have something, though. What do we get? 5,000 science is a decent amount. We can get a couple of technologies and hopefully have enough for a crewed mission to Duna. And before we go, do we get any new missions? That's not happening. Not right now, at least. That is a big ask as well. Could maybe do that. This we could probably do. 10,000 science to land on Tylo. It's fine, we'll track it. Let's go to R&D. What can we get? I really want that Mammoth 2 engine. It's really powerful. Also need radiation science as well, so we can start getting more science by measuring radiation levels. I like building planes, but I'm terrible at landing them. We're not going to worry about aerodynamics for now. The nuclear power would also be useful, but I don't think we can afford that. Large panels will help us in Jool, but we don't need them for a crewed mission to Duna. That is also really nice to have. The cockpit as well would be really nice. Okay, well, no matter what, I know I want the Mammoth 2 engine. I want the radiation science. This was 1,700. Don't really need those, we can't afford those yet. Don't really need a stack separator. I don't use them very often. Trusses right now either. I guess we're gonna save the rest of our science for now. And, you know, we could probably afford one of those if we can get our Jool satellite a little bit closer, maybe to one of the moons, get some extra science. So let's see what we can do. What even is this? What am I looking at? What is fly safe?
Okay.
Oh, that's our giant satellite. Okay, we need to change the name of that. Forgot that we renamed it before I reloaded the save.
Admiral Adjusted. Aloha Edra.